we talked about interfaces and functions, right, in Starknet smart contract, and then we sort of like went through and write a contract that basically increase and decrease a counter, right? And we saw where all of what we talked about came into play, right? Where we saw where the interface are defined, we see where they're being implemented, we see some annotations that tell us that this is a Starknet smart contract, right? And we also create like a scaffold with SMForge, right? And so people were able to sort of like build what we worked on during the class, and we were able to successfully build that particular contract that we worked on. So yeah, that's like a recap of what we discussed on Monday. And today we're going to continue from where we stopped, right? A continuation of what we did on Monday to go deeper into building Starknet smart contract. I'm hoping today we can be able to build 3 contracts, two at the very, like, I'm hoping we can be able to do 2 or 3 smart contract, right? Depending on how I'm able to carry everybody along, right? So I'm going to share my slide and then we can kick off. Okay. Okay, I need to share my screen. Okay. Okay, if you guys can see my screen. If you guys can see my screen, just signify. Can you guys see my screen? Awesome. So yeah, today we're going to go deeper into Starknet contract development, right? And we're going to talk about writing a simple storage contract, right? Which is something that we did last week, something that we did on Monday. But today we're going to write a Starknet smart contract using the class example I gave on Monday. And then we'll try to understand what we mean by event, thread, and system call, right? And then we'll try to see cross-contract interactions and libraries, right? And then we'll look at modules and scope in Starknet. So yeah, the first section of this class is writing a simple storage contract. And what we are going to do is we're going to write a classroom contract that has the following functions: add a student, update student grade, and get a particular student details. So yeah, let's begin, right? So I'm going to share my terminal, right, and run a fresh scaffold. And run a fresh scaffold of the project we're going to work on.
Please, sir, we are not seeing your terminal.
Yes, I'm about to share this, my terminal. Can you guys see my terminal? Awesome. So just like we did the other day, right? If you want to scaffold a new Starknet smart contract project, you do SMForge init, and then the project name. In this case, we are going to call it classroom. I'm aware that I'm very sure you guys from my class on Monday, you guys understand what I just did here, right? It's using SM4 unit to create a new project, and it's going to ask us, do we want to use Starknet Foundry or Cairo tests? At best, is we use SM Foundry, because SM Foundry comes with some features which you talked about in the next Cairo sessions, right? In the next classes, which is writing tests for Starknet smart contract. So I'm going to go ahead. Is someone raising his hand? Okay. Onyekachi, you can unmute and speak.
Sorry, I can't see your screen. I'm just seeing your logo, but I can't see your screen at all.
Is this the same thing with other people? They can't see my screen?
Maybe she should log out and try logging again.
Exactly. Yeah, I think it will be, yeah. Most of the times these things happen. When your network is a bit not strong, you see you won't see the next screen that has been shared. So yeah, try going out of the call and joining back. I'm very sure you have a good experience. So yeah, I'm going to stop sharing and then share my VS Code screen, right? And okay. Can you guys see my screen now?
Yes, we can see it.
Okay. Okay. Is the okay. Is the text clear enough? You guys can see the text? Okay. I'm going to add this folder to the screen.
Please increase the font. The fonts, they're too tiny.
Okay.
Command plus.
Like they're too tiny like this.
Okay, it's better. It's better. It's better. It's better. You can even collapse the Explorer.
Yeah, going to do that. Awesome. So this is the contract we wrote the other day, right? So in this class today, right, so we're going to work on a fresh contract. What I'm going to do is this is the scaffold that it gave us. I'm going to remove everything. Now our classroom contract will have the following, right? Add student, update student grade, and get student. Now, who can remember the first thing you want to do when you're trying to write a Starknet smart contract? Anybody?
Okay, you bring in the interface, the Starknet interface.
Awesome. So the first thing you want to do is you want to create your interface. So basically, first thing you want to do is you want to create an interface after you sort of like understand what the contract is going to do, right? And like we said, right, the contract, the interface are like the blueprint, right? Sort of like look at it as like the drawing that the architect gives you, right? So once the architect has finished drawing the design, he gives it to you, and then you now give it to your structural engineer, your building person, and your cement and your mason. Then they now start digging and start building. So yeah, that's like the first thing we want to do here. So we want to start by defining our right. So and then the first thing we want to do is we want to do it. Done. You want to start with Starknet interface. Yeah. Okay. You want to say Starknet interface, and then you define. You said pop thread I classroom. Yes. So so it is sort of like a best practice to sort of like define it based on your contract name. So if your contract is classroom, your interface will be iClassroom. If your contract is vote, your contract interface will be iVote. But this is not cast on stone. You can define it however you want to, right? And remember we said it's going to contain two contract states. Two contract states. These two contract states, when we're implementing the contract, will give us access to the contract states. The first two functions are write operations. And remember we said when you're doing a write operation, you are referencing the state. Something to contract state. When you're writing to the states, we are changing the states, you're referencing the contract states. Yeah. The second one, yes. So add student. What do we want to add for that student? We want to add his ID. Take a look at, yeah, we want to add the student ID, the student name, and the grade. Remember what I said the last time? That your function argument can take more than just the reference to the state. And this is exactly what we're doing here. We're going to collect the student ID, which is going to be a file 252. Yes. Who remember this file 252 during your previous Cairo class? Awesome. So in Starknet, every variable that you declare, if you don't give it a type, is going to inherit file 252 as the default class. Yeah. So if you don't want your variable that you declare in your Starknet contract to default to file 252, then you give it a name we give it the right data type. And remember, we have other data type, right? Aside FL252. We have byte array, right? And then we have the unsigned and the unsigned integers. And many, many more. Next thing we want to take the name. And name, it can be a byte array, which is more than FL252, but because we're writing a contract and we want to ensure efficient use of memory, we use FL252. Then the grade. Grade is going to be a U8. Yeah, let's do a U8. Okay. Okay. That parameter must be a self. Okay. Who noticed what we have? Exactly. So I mean, even from the compiler, and the good thing with the Scarb, which is the language server of Starknet, if you are writing your code and it's not going according to how you should write it, it will be throwing you some compiler error. So you can basically resort to, and you can see from here, plugin diagnostics, first parameter must be named self. Yeah. So this is one of the good things that you get when you're using Cairo, when you're using a compiled language actually, because the language server will tell you if we basically identify that if you are heading on the wrong direction. The next function we want to write is upgrade student. Okay. Is it update? Yeah, update student. Yeah, update student. Okay. And basically we want to update student grade. So same thing. It is a write operation. So we have to reference the state to contract state. The contract state, the student ID file 2 by 2. And because we are trying to, again, you can decide to do update the name or grade, but in this case, I want to update the student grade. So I'm going to do this. So if you're working on this, you can decide to sort of like add an extra function that basically updates the student name. Now, the last thing is get student details. Sorry, get student. Yes, and it is a read operation, right? So we're basically taking a snapshot of the contract state. So get student. So yes, this is this. The @ symbol is what tells us that we're trying to take a snapshot of the contract state. And what do you want to return? Now this is another interesting another interesting thing here. We want to return students. And student is a struct. Remember your struct? Yes, it's going to shout. It's going to shout just because it can't find it, right? So we need to define struct. And in defining our struct, we need to add some derived thread, right? So we can come up here and say struct student, basically student L252 grade L252. I hope you guys are following. If you're following what I'm doing, just signify with an emoji. Awesome. So you guys know I'm using a struct here, right? And you understand what a struct means. Okay. So struct basically allows you to group data. Yeah. So thread has no implementation in context. So yeah. So there are certain thread that we need to add for our Starknet smart contract to be able to allow us to use structs. And those threads are this. So basically it's a derived thread that has the copy, drop, seed, and Starknet store. So Starknet store is which allows sort of like access the store, right? Of the storage slots of structs. And then the copy and drop are basically allows to copy this struct, right? And then the drop. So the moment the what did I call it? The contract, the moment we're done running the contract, this struct will be dropped. So yeah. So this is why we're using some of this trait. Now, next thing we want to do now is start our contract module. Remember the last class we said Starknet smart contract are basically sub-modules, right, in Cairo. They're basically modules in Cairo program. And we want to start writing that is by going ahead to this pop mode classroom. Now, the first thing we want to do is define our storage slots. Yeah. Yeah. So we want to do students, which in this case is going to have what we call map. So map, it's sort of like a data structure that, I mean, from the name, basically map certain keys to certain values. And in this case, we want to have a map I want to map student ID to student struct. I hope you guys understand what I'm doing here. Is there any question from anybody from what I just did here? So we have map, we have vectors, right? But here we're going to use a map, and that map is going to carry a type of file 252 and student. Okay, I can see somebody is raising his hands. Okay. Yeah, Joa, you can go ahead. Oh, okay. Joa, you can go ahead. Okay. Let me try and answer some of the questions I see from here. Hillary is asking, is file 252 more like a string data type or an integer data type? It's sort of like it's a string data type. It is string data type, basically. Then the second question from Moses Sunday, what does that map data type really do to data? What does that map data type really do to the data, the structure? So yeah, so I mean, from the name, right, map, you're trying to map to some items together. And in this case, the map basically allows you to map a particular key to a particular value. And I said, I want to map the student ID to the student struct. Yes, so it's throwing an error for us here because we need to import the struct. We need to import the map from Starknet. So Starknet has some inbuilt data type that you can use. Take it for example, your everyday inbuilt library functions, right? From JavaScript background, your reducers, your map, they're all coming from the language, right? So yeah, there are some certain data type that comes from Starknet core, where you can basically just pick and use. And map is one of them. And that's why it's shouting here. We need to import it before we can use it. So I'm going to go ahead and import it. Okay. I'm going to go ahead and import it. Use core Starknet. So yeah, it's actually shouting. So why is it shouting? So that one. And if I understand it correctly, it's shouting because we are trying to import it the wrong way. So map, it's a storage data type. Map is a storage data type, right? And for us to use it, we have to use the storage, and we have to use the storage to do that. Yes. So yeah, it's also going to shout because it's supposed to be storage. And with the new Scarb version, if you're going to use a map, you need to import the read access and the write access. And They are storage. I don't know why it's not bringing exactly. Yeah. So you're supposed to read access. Yes. Yes. So another thing that we needed to import, we need to bring in this structs and the classroom into this scope. Remember the last class what I did was I basically do this, right? For me to import it, what I did was I basically did super and this. So I'm going to show you another way to do this, right? Which is to basically do use super and this. Okay, so students, and I wanted to import all but showing some errors. So let's go with the convention of importing just the items that we need. So you could see here, because I imported it into this module, is now being accessed in this scope. Did you guys understand what I did there? Any questions so far from here? Okay. Let me look. Do we have anybody with any question? Can you guys, if you can see my screen, can you guys just signify with an emoji? It's like Destiny is having.
Yeah.
Joel, do you want to speak?
Sir, please, can you come again on the use super and use core macros? I don't really understand.
Okay. Use super, right? You're trying to bring some certain data into scope of your module. And because they are above you, they are defined above, right? For you to get access to them, you have to use the super class. Not super, not a class actually, but you have to use the super stack to get access to it. So you use super, which means you're trying to access everything above, and then you now open up and import what you want to use. So in Cairo, if you want to import data, you have to use the use keyword. And then, are you clear on this one?
Yeah. I get the use super.
Yeah.
So
Then,
basically, the students and I classroom data are not on this class. So you imported it from the interface, and
yes.
so that's why
Yes.
you use
So
the use super.
yes. Students and iClassroom are not in this module, are not in the classroom module. So for me to use, for me to get access to them and use them, I had to import them. And that's why I'm using, we had to use super to access what's outside the module. Yeah. Then for use core, Starknet, and then this. So Starknet gives us access to some certain core features that we can basically just pick and use in our Cairo contracts, in our Starknet contract. Yeah. And one of them is this this storage that give us access to map. And I'm very sure during the course of your engagement within the Starknet ecosystem, you will see that some contract are not using this storage, are not using this. They are using what we call legacy map. So from the new versions of Scarb, that legacy map is no longer in use, right? So we're using map, we're using storage map. And if you want to use storage, if you want to read from that storage or you want to write from that storage, you have to import the storage map read access and the storage map write access. I don't know if that makes sense.
Yeah. I get.
Okay. Then we come here, we define student. So student, we said we're going to have a map. The map, the student ID, which is a type file 252 and student struct. Okay. So let's continue. The next thing we want to do is we want to also keep track of the teacher. And for the teacher, we want to keep track of the teacher's contract address. And what we want to do with the teacher's contract address is to basically set the teacher so that only that teacher can add student and update student grade. Does that make sense? Okay, awesome. I can see some emojis, which means we are on the right path. So I'm going to be a bit fast here so that we can quickly yes. Like I said, right, the teacher is we're going to collect his contract address, and yeah, we're already seeing that it's shouting to me that, oh, you're writing contract address, but you don't have it here. So contract address is the data type in Starknet that tells us that this particular data we are collecting is a contract address. And again, Starknet give us that contract. Starknet core give us the contract address type. The moment I go like this, yep, you could see it has it for us there. Just need to import it, and we are done. This will stop shouting. Now, before I proceed, right? A quick question here, right? If you want to make it such a way that only one teacher can sort of like add student and update student record, right? Where is the best place for us to set that student? Does anybody have an idea where we can set that teacher such a way that only him can add student and can also upgrade student details? Does anybody have an idea where we can set that teacher?
I'm not sure, but let me try.
Okay.
So, yes, okay. I don't know. I'm thinking probably we should put it in the constructor, although I'm not sure.
Be confident in where you're, like in your response. That's exactly where we are going to put it. Because, like I said, right, constructors are called only once during the contract deployment. The moment you deploy the contract and you pass in that user address, that address is the only one that can add a teacher, sorry, that can add a student and also grade it, student details. So yeah, nice one. Okay, yeah. I'm can see people raising their hands up. Joel, you can ask a question. You can unmute and ask a question. Okay. Please, you can unmute and ask a question.
Hello, good evening, sir.
Yes, good evening.
Okay, so first, please pardon the way I'm going to ask the question because I'm just learning it. I don't really understand everything. So how will this teacher work at this job that you call it now when you did not define it as the I class?
Wonderful question. Good one. Good one. Yes, so again, that comes back to the way you want to design your contract, right? Now, I want you to when you're writing your contract, right? Think of what that contract would do before you actually even start writing the code of that contract. Because writing the code is like the easiest part, but thinking through and designing the contract, right, is what you need to do before you even actually writing code for the contract. So yeah, now that's where we need to think, right? What would teacher do, right? Is there anything that we want to do about teacher? Is there anything we want to do to the teacher? From our interface definition, no, right? And that's the scope that we want to stick with the for a teacher, right? You can decide to say, okay, you want to map a teacher to a classroom, right? And add an interface function that says, okay, if this caller of this function is a teacher, fetch me his classroom details. That's something that you might want to think of, right? But here, we just want to add student, we just want a teacher, right, to add student and sort of like update student record. And we want that teacher to be, any teacher that deploy the contract will be the one to be in charge of that classroom. Add student, update student. So if another student want to sort of like, if another teacher want to, let's say teacher A in class, teacher A in class 1 want to deploy this contract. When he deploys it, he can keep adding his teachers from students from all class 1. And if a teacher from class 2 want to also add the student, what he will do is deploy the contract, right? And only him can add those students. So that's the design thinking that we have here. So that's why we do not add any function that has to do with anything that has to do with the student. But this is just like a design that we thought of, right? You can decide to do it based on how you understand it, right? Based on how you want the contract to do for you. Do you want to add teacher details? Why not? Do you want to add to say, okay, at the time of deploying this contract, I want to add a certain number of teachers that can only add students. Maybe you say, okay, this contract teachers can add students at the same time.
If you are using 18, that's cool.
Somebody speaking? Somebody speaking? Okay. Okay, the person just made himself. Okay, awesome. So yeah, so the thinking here is we want the student we want only the teacher that was declared at the point of deploying the contract to be the one to add student. And that's why we'll have a constructor that basically add a teacher to the storage slot. Okay. And I'm going to have, yeah, contract address. Contract address. Okay. Contract address. And anybody, there's something we missed in this in this contract module definition. Can anybody point us to what we miss and why this is shouting at us? Anyone? Okay. So it's shouting at us because we did not declare it as a Starknet. We did not declare it as a Starknet contract. We did not declare it as a Starknet contract. That's why it is shouting at us. Aha. So you could see, remember we removed that, we made it to be this, stop shouting. So now, every time we deploy the contract, it's going to call this constructor, and then this constructor is going to sort of like do something, add that teacher, so that every time we want to add the student or guest of the student record, we check that the person calling this function is a teacher. I don't know if that makes sense. If you guys are with me. So I'm going to, okay. Right? Remember, when you want to write to storage data, you do like this, right? Exactly. And remember, from your Cairo knowledge, if you this constructor is basically a unity for it's sort of like a unity function that doesn't return anything. So that's why we're leaving it here and we're not returning anything. So it's return null. So yeah, that's it, right? So now we want to go ahead and implement our interface. Remember the last class we said every time you create interface, if you're implementing them, all the functions in the interface has to be implemented. So I'm going to come down here and we'll do what we call ABI. No, we'll do what we call ABI API. ABI embedded, right? And remember, in the last class we said this adding this annotation is basically telling the compiler that, okay, when you build this project, expose the ABI for us, so that whoever is trying to consume this on the front end can basically look at the APIs and pull out the functions of the contract from there. So yeah, now what we want to do is say, remember the keyword in, yeah, classroom of I classroom, yeah, yeah. Remember that? I classroom implement, right? So why is it shouting? Exactly. Why is it shouting? Exactly. So you can name this implementation whatever name you want, right? So we just implemented, right? And then what is the shouting? Shouting that not all trade items are implemented, missing add student, update student, and get student. Awesome, right? Who remember this from the last class? Awesome, awesome. So I'm going to go ahead and quickly implement those two functions. Then I'll go over them. Add student. Yeah. Contract states. Yeah. Student. L252 name L252 and great U8, right? And doesn't return anything, right? So now remember from our design, right? We said only a teacher can add a student. So now I'm going to introduce you guys to another concept here, which is the concept of assertion, which is the concept of assertion. So assert is basically trying to check that this, if it is it's basically trying to assert certain scenario, right? And assert basically returns error if the check is false. So there's another, our super cool Starknet core is here for us again, and he gave us something very interesting and awesome, which is get. And you see, it gives us a lot of options here, but we're only interested in get caller address. So whoever is calling this function, when I do get caller address, I will get the person calling this function. I will get the address of the person calling this function. Now, if the person calling this function is not, now, first of all, before I even do the check, I need to read the teacher. Yeah? Because we're trying to test against his address, right? So teacher dot, yeah. When you're reading from the storage, right, you do the self.teacher.read, right? So we want to do a check of this address. If they're not the same, which means if this check is false, assertion always throw error if the check is false. So what do we want to put it as the error message? Exactly. Only teacher can, only teacher can add student. Now, so remember how you throw errors, right? In Starknet, we use assertions. Yeah, and this assertion, there's other one which is panic, right? Which is basically also halts the function execution. Now, if you know that if this thing is true, it will not run this. It's going to continue to the next line. But if it is false, it's going to run this error. So yeah. So what do we want to do? We want to add the teacher. So we want to say, we want to add the student. So we want to say, let student yeah. Remember this our awesome structs. Remember it? The one we defined above. Awesome. I like when I see this. This is a typical mistake that developers make while writing code. Can you see what I'm getting here? If you can see what I was highlighted, can you respond with an emoji? Awesome. It's saying that student unexpected argument type expected core fell 252 but found core integer U8. You encounter this error a lot when you're writing contract. Now, let me explain why we are having this, right? Now, remember, when you go up, remember our grade is saying is fell 252, right? Yeah. And up until this point, we're saying grade is 8. Yeah. So you are passing a grade of type U8 to a grade of fell 252. It's not going to work. It's not going to work. So if you define a type of fell 252, you can only pass it a type of fell 252. If you define a variable of U8, you can only pass it value of U8. If you pass it value of fell 252, it's going to shout. And this is exactly what's happening here. We expected FL 252. We were passing a grade with type of U8. So I'm going to make this U8. And yeah, we have this gone. Did anybody understand what I just did here?
Please, sir, come again, please.
Okay. Let me resolve back to error. Now, we define a type of structs, and the fields in that struct of student are accepting a name with type of fell 252 and grade with type of fell 252. Now, when we come to this function, we say that the function is accepting student ID, name, and grade. The student ID is fell 252, is of type fell 252. The name is also of type fell 252, and then the grade is type U8. Now, we are trying to create a student from this struct. And the struct has a definition of what? Grade and name and grade. The name is fell 252, right? Which is what we are passing here. It's defined as fell 252 here, right? And from this here, the name is file 252. And that's what we're passing here. Can you see? That's why it
Yes.
did not shout. Now, the next one is student. And the student has a grade of 252. Right? Now, we have a grade of U8. And then we are passing it to a grade of 252. So essentially what we're doing here is we are passing a grade of U8 into a
Felt into a U8.
going to throw an error because the types are not the same. I don't know if that makes sense.
Sure.
So we have to convert them to the same type. And I'm going to convert them to U8. And the moment I do that, it's going to stop shouting. Because U8 is accepting a U8. U8, yeah? U8. So yeah. Now, we want to write to the storage. We want to write to this contract storage. Now, we want to even do let? No, we don't. We just want to return this dot student. Yeah. Dot write. Now, because it is a map, the writes will carry the key and the value. And in this case, the key is going to be our student ID. And then the grade is going to be student. Remember our mapping student ID and student struct. Mapping student ID and student struct. Remember? So it's personally, right? I always, whenever I do a map, I always try to comment by the side to show the mapping. So that when I'm implementing it, I know exactly what I'm passing into the key and what I'm passing as the value. Are we on the same page at this point? Do you have any question? Do you have any question? You can always ask questions if you don't understand. Exactly. Type safety for less errors. Exactly. Does anybody has any question?
Yes, I have a question.
If you okay,
Okay, you
go
said
ahead.
the grade struct was showing error because the data types were different. So yeah, I didn't see how
Yes.
you like solved that issue.
Okay. Let me come back to it.
Okay.
Now, let me rewrite it to file 252.
Okay. Yes.
Now, can you see? Look at the error
Yeah.
addition. Unexpected argument type. Expect a file 252, but found integer, but unexpected type. Expect core file 252, found core integer U8. Can you see?
Yeah.
So
Thank
the
you.
compiler is basically telling you that if you define a variable or a struct field as type U8, you cannot pass it a value of 252. It will not accept it. So if you define a variable as file 252, you have to pass in a value of file 252. So that's exactly what happened here. So now if I go back up and I make this U8, it's going to stop shouting because we are passing a file 2 of U8 here to this U8 class value. Does anybody has question onto what we did here? Okay, I'm going to go ahead to the next function. Fn.
Sir, please,
Okay.
can you hear me?
Yes, I can hear you. Go on.
Please,
Go on with the question.
can you explain this line 44 again, please? I think I joined very late. I last
Line 44.
That's the last. Yes, the self dot students dot writes. Yeah.
Okay. Were you at the last class, the Monday class?
Yes. Yes.
And you understand that when we are writing to storage or reading from storage, you basically do a dot on the storage slot name, right?
Yes.
Yes. And while we are doing why we are adding this to this is because this student storage slot, it's a map. Go up here. Can you see here? It's a map. That map a FL252 value and a student struct. And this FL252 is student ID mapped to a student struct. Do you understand?
Yes. I'm following. Yeah.
If it is just a normal value, just like for instance this teacher, can you see? It's just a value, just a variable, just a value that accepts a particular an address, right? It's not a map, just a value that accepts one value. You write it, you basically just do self teacher address, right? You point to that storage slot, dot write, and then you pass in the address. Can you see the difference?
Yes.
So depending on what you're trying to do with that storage slot, depending on how you write to that storage slot or read from that storage. So there are other storage type, right? Like vectors, but let's understand this map because a lot of the time when you're just Starknet smart contract, you use this map a lot. So it's very important that everybody on this call understand what this map does and how you can push data to the map and read from the map. But I hope this answers your question.
Yes, thank you so much.
Awesome. So the next thing is we want to update students. Now again, we want to check, is this person trying to call this function, is he the teacher? And that's exactly what this function is going to do. So I'm going to basically just copy this line. I know some people might say, why are we duplicating code? Yeah. For now, we'll duplicate it. But by the time you sort of understand the fundamentals and sort of like understand how the flesh and everything works, then we can start to think of optimizing the code and doing some stuff around writing, calling some functions that does some of these things for us without having to repeat the code everywhere. So yeah, remember we change the message. Only teacher can update. Is it updates? Yes, update student. There's something that will shout here, and it's something the compiler will shout here, and I like that it shouts here. Something that you guys need to know. Aha. The value, can you see the error that is saying? Can you guys see what it's saying? What this error is saying? The value does not fit within the range of time. File 252. So what does that mean?
Okay, I think it means since it's a short string has a limitation when it comes to the length.
Exactly.
So
Exactly. So basically, it means that this assertion this assert has two values, a bool and a FL252. So this return a bool, and the second one is FL252. So this is a bit tricky in terms of the messaging, right? But we can basically say cannot update student record. Awesome. So you could see that the value has filed within the FL252 range. Awesome. Now we want to go ahead and update student record. We first of all get the student record. And again, right, because it is a map, we can filter data by keys, by the key, which is this user ID, this ID here. This is the key. This is the value. So we can say let student cross reserve dot student dot read, because we are reading the value, right? And again, because it's a map, we can read and pass in the key. And the key here is student ID, which is FL252, and it's expecting FL252. If this is a U8, it's going to shout, obviously. Now, these are some crazy errors in Starknet that you don't want to encounter when you're writing code here. But it's basically a type issue. Action. So now that we've gotten that student, right, we want to update his grade, because the grade is what we just collected. Now, remember in your Cairo class, if you want to get a particular value from if you want to get a particular field from a struct, you basically do the student, in this case the struct, and the field name, right? In this case, we're going to say grade. Yeah. Aha. Awesome. 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 I'm going to introduce you guys to another concept, which is called, okay, I'll ask you, why are we having this error here?
okay, I think it's because of the mutability, something like that. So we need to
Awesome.
make students mutable to be able to change it.
Awesome, Gideon. Awesome, Gideon. So yes, so in Cairo, by default, you can't mutate value. If you want to mutate value, you have to define that I want to mutate this value. And that's exactly what's happening here. If you want to mutate this struct value, you have to say, okay, this is mute. And then from there, we can basically give it the new grid. And from there, we save the value. Yeah. So we save it, right? We do self student dot write. We do student ID and student. Awesome. Now Did anybody understand? Does anybody has question regards here? Anybody? Okay. If we are all on the same page at this point, can you guys signify with an emoji? Prosper, do you have a question? Your hand is up. Eric,
Please, why is the compiler still shouting?
why is the compiler still shouting? That is here,
What,
right?
yeah, line 34.
Exactly. It's shouting because we've not completely implemented all the interface treat. We still have one missing function in the interface treat that is not implemented.
Okay,
So,
that's cool. Yeah.
so when you define interface, then you have to implement all of the functions in the interface. And that's what we do here. So let's come here and do the last one. It's a read, right? So it's going to take a snapshot of it. And in this case, anybody can read. We're not going to restrict anybody from saying, do you can't read. Anybody can come and read. Yeah. And yes, it's going to collect the student ID. It's going to collect student ID. Okay. It's going to collect. So what I'm going to do here is, you're basically going to read a particular key value, right? So you're going to do student dot read dot read dot read student ID. So yep, that's all. Like literally that is it. So yeah, does anybody has any question from here? Any question?
So sorry, please. I want to ask, where
Okay.
did you declare your upgrade variable? Like, what's the context of the upgrade variable?
Upgrade variable, it is at the top here. It's a struct, it's a value, it is a key value in the student struct. Can you see it here?
Yes, but on line, I think 31, you said self dot student equals upgrade.
31.
31, go down.
Oh, 51. Yeah. So
The okay, sorry.
yes.
Can you just explain that?
Yeah. If you want to access struct key values, if you want to access struct name fields, you use the dot notation. So because from here, right, when we do the student.read using the student ID, we are reading a struct. We're getting back a struct from here. From this map, what you get is a student struct that is being returned, which is a student. And which gives us opportunity to do student.grade. Remember, the student, struct has a name and a grade field. And with dot notation, you can access those struct name fields. And that's what we're doing here. Student.grade, I'm passing the new grade that we want to pass. I don't know if that answers.
The upgrade. Like,
Yes.
where did you get your upgrade? Like, you say
Yes, the upgrade is coming from the function arguments. Can you see? It's collecting student, then the new grade level. The student with.
Okay. I've seen it.
Awesome. So I'm going to go ahead and run on my terminal. I'm going to go ahead and run Scarb FMT. so that it will format it. Yes, awesome. And then I'm going to do Scarb build. Awesome. So we've just finished, like we just built the contract, right? And yeah, this is what we just discussed here. So all of what we talked about here, we just implemented them here. Add student, update student grade, and get student. So yeah, in the absence of any question, okay.
Okay, please, can I see your constructor function?
Okay. This is my constructor function.
All right, thank you.
Awesome. So I'm going to push this code to GitHub and sort of like share the link to this with you guys so that you can always reference when you're working on this thing. And feel free to sort of like add more features to this function, right? Because it's something that you can always update it, and it's good that you sort of like write your own contract to where you understand. So yeah, I'm going to stop sharing my screen and share the slide. Okay, so we can quickly run through the slide and see if it is possible to. So yeah, we just did all of this right now, right? The classroom contract, we have a contract that added the following functions: add student, update student grade, and get student. And we've written that. And then yes, section 2, understanding event and system call. So I'm going to explain them via the slide, and then we will go into this function, into this contract that we just write, and add events to them. So what are contract events? Contract events are custom data structures emitted by smart contract during execution. They serve as communication mechanism between Starknet, between smart contract and the external world, allowing contract to log important information about specific occurrences. Now, events are particularly significant for integrating smart contracts with real-world applications. For example, in the case of non-fungible tokens on Starknet, an event is typically emitted each time a token is minted. This event is then indexed and stored in a database, enabling application to display relevant information to users almost instantaneously. Events are a powerful feature in Starknet contracts, allowing for efficient login and external communication. They are essential for building responsive and interactive decentralized application on the Starknet platform. Exactly. So all of this English is basically telling you two things. You use events when you want to communicate what's happening in your contract to the outside world. Secondly, when you want to log your actions that happen in your contract functions to the outside world. So take for instance, you want to send every time a user comes and sort of like, yeah, exactly. This is a very good use case here. You have a system that it's a student management system, right? Where teacher adds student, right? But we want to keep that student record on the blockchain. So the moment you add that student, right, you dispatch an event. And maybe you have a backend that stored that user ID with his email and all of that. So the moment that you add that student on the blockchain and that event is being dispatched, and use indexers to capture that event, you can sort of like send that user an email, right? From your, I mean, the contract is done, you send that event. You remember you picked up that event, you can do whatever you want to do with the event, send email, log it to a Slack, anything you want to do with it, right? So that's the power that Starknet that events give you. So yeah, system calls. So system calls are low-level functions powered by Starknet operating system that allow smart contract to interact with Starknet environment. System call are predefined functions that provide core functionality for Starknet contract. They allow contract to perform operations like getting contract address, emitting event, or calling other contract. System calls are not defined by the developer, but are provided by Starknet system. So yeah, let's go back to the code and we'll add events and we'll see an example of system calls also. So yeah, I'll stop sharing my screen. Okay. Can you guys see my screen? Awesome, awesome. So yeah, we want to add events. And how do we do that? We do that by, first of all, defining the structure of the event data. And events are basically defined as sort of like structs. So we can come here and they have their own annotation. That's the beauty of it. They have their own annotation. The annotation is student L252 and done. Exactly. Student added. Want to have student ID of L252. And we're going to have what we call the grade of U8. So why are you shouting? Okay. Now,
typo error.
Okay. I'm not exactly sure if it is a typo error, but then we'll figure it out. Invalid drop trade, yeah. Okay. So plugin failed to generate type invalid struct. Snapshot has unused generic parameters. Okay. Okay.
Barak, I think felt is spelled incorrectly. I don't know if that could be the error there.
Yeah, exactly. That could be okay. Thank you for that. Okay, so yeah. So we'll go ahead and do the second one, which is grade updated. Yeah. Grade updated. Student grade. Okay, student grade updated. Now, for you to define trade, you have to add this. Why are you shouting? Yes. For you to define your struct and to say that this struct is an event struct, you have to pass in this annotation, drop and Starknet events. Yeah. So what it basically means that is signifying that okay, this is a Starknet event, and when you finish dispatching it, dropped it. And the second one is an enum. An enum is basically, as the name sounds, right, is an event that basically store all list of events. So if you have more than one event here, you can always come here and define them here. And yes, you also have this annotation of event, and then it has this event drive drop Starknet event. So the moment you finish dispatching this event is going to drop. At the end of this, the module is going to be dropped. So yeah, this is how we define our event struct. Now, does anybody understand? Has any question from what we just did here? Oh.
Sorry, I don't really understand the event I don't really get it.
Yeah, so what I did here is I defined the structure of how I want the event to be, how I want our event to emit our data. So I wanted to emit it as a struct. I mean, it's always struct event in Starknet are always emitted as a struct, which is basically a data structure that has name, field, values. Yeah. So this is the first event. The first one is student added. Second one is student grade updated. And we always have an enum that tell us, that keep track of the list of events that we have within our contract. And those enum is defined here.
So sorry, can you come again on what an event is? I don't really get that part.
Yeah. So events are basically sort of like data structure that dispatch event from your contract to the outside world. And for example, when you add a student, you want to communicate it to the outside world. So, okay, I just added a student, then you dispatch that event. There might be an indexer, or yeah, that's sort of like index that event. And maybe you have a backend. You're building like a student management system, and then you have a backend that listens to that indexer whenever this event data is being dispatched. Student added, I basically pick the student ID, go to my database, fetch that student record, and send them an email. Okay, you have just been added to level 2 second semester. You get how the interaction from the Starknet, from the contract part works up until to the outside world. So just see event as sort of like that data structure that communicate whatever is happening within your smart contract to the outside world, to the external, to anything that is external to that smart contract. I hope that makes sense. Awesome, awesome. So now that we declare this, right, let's go to our contract. A lot of the time, right, contract events are emitted as a result of rewrite operation, but some dispatch event from read operations also, but a lot of the time you dispatch event as a result of write operation. And in this case, because I mean from the name itself, right, student added, you're basically going to dispatch event from here. So we're going to come down here and basically say self.emit, yeah, student added, student ID, and grade. Yup, that's exactly it. You just emit every time you call this function in your contract. You call add student, he added it, done with everything it's doing, is going to emit this event. You have what we call indexers that listen to that event that is being emitted and maybe call another system and send this message to another system. Yeah, so that's exactly what it means. So now then we come back here. Exactly. Come back here and said self.emit. What do we call it? Student grade updated. Yeah. We also have the name, student ID, and the grade. In this case, yes, and the grade, I will just yes. So you don't pass in this case here. And again, why is it shouting? Why is this saying something different? Name, student grade updated. You pass in the name. Oh, okay. Yes. Variable name. Yes, so our function does not pick students. So yeah, awesome. So there's this thing that you can actually do. Let me try. I'm not exactly sure it's going to work. Oh, it did. So that means this. Oh yeah, this student struct leave up to this point, but anything after this point is going to be dropped. So yeah, this is how you emit event from your contract functions. So yeah, does anybody has any question from here? Yeah, you can go ahead. Unmute your mic and ask.
GM everyone. You said something about this second event when you are emitting it.
Yes.
And what was the error and why did you have to use student.name? Like
Yes.
name is
Yes. So if I do like this, in this whole of this function, is there any place where we are passing name, either from the contract, from the function definition, the arguments, or anywhere in the function? Can you hear me?
I can hear you.
Yeah, is there anywhere we are calling name apart from this place in this update student? Is there anywhere we are calling name apart from
No.
these two? Exactly. But remember, our struct has grade and name field there, right?
Yes.
So if you do like this, you have access to it. Because the student struct live up to this point. So at this point, you can access it. But anything outside here, you can access it. It's out from here.
Okay,
That's
thank you very much.
that's the first one. The second one is we want to set grade. It's the same thing. The same thing. There's no grade. Is there any place that we set grade here?
No.
There's not. Even though this is like a not so cool way of adding, like saying this is a grade value, right? So but yeah, there's no other place. So that's why we now have to do this upgrade. Because it is a grade value that we are passing. Yeah. Okay. So anybody with any question again?
Okay, I don't know if I can ask my question.
Yeah, please go ahead.
Okay, I wanted to ask that the constructor, because I think there was one time I overheard somebody saying they used is it initializer function instead of constructor function. So I wanted to ask, is there like any alternative to constructor function?
There are so places where you use initialize functions are most cases in components. So when you start to go into components, you will see where we define functions called initializers, right? And then when we import those components into our contract, in the constructor, we basically call that initializer. And that initializer sets the ground rules for us.
Okay. I think I understand now. Thank you, sir.
Yeah, so okay. Now let's like compile again. Yeah. Let's compile this program again, then we move on to the next. Anybody would okay. Yeah, you can Wisdom, you can go ahead and ask a question.
Gideon said something about initializers.
Yes.
I think the initializers, I think is inside the constructor that you can put it in. Something like that.
So initializers are basically functions, right? And they are being put in, most essentially they are being used in components, right? So when you import your component into your contracts, when you want to use an initializer to set some ground rules. Let's say, for example, you want to set, okay, only this color, set the owner of the contract, then you can use initializers to do that. Or maybe just in case of what we did here. If it is a component that we have that we're importing, we can have an initializer that basically then we can basically call in the constructor and it does the same thing that we just did here. If it is expected to do what we just did in the constructor here. I hope that answers your question. Awesome. So the contract just compiled, right? So I'm going to go ahead. Yes, so I'm going to explain to you guys system calls and some of the where we'll be using them here. So you could see here, right? Can you see here where yes? Can you guys see get caller address. Get caller address is a system call that the developer don't need to care about. You can basically just call that function, and it gets you the person calling that contract function. Every time you call a contract, if you want to know who called that contract, who called that contract function, you can basically use this system call function, get caller address. And that's like an example of a system call function. There are others called executes that does execute certain transactions for you. And there are a lot of them. So we'll see them as time goes on. Cross-contract interaction. So, okay. Now, here we're going to build two contracts that shows cross-contract interaction. So, I would say let's take a bit of like 30-minute break, right? And we reconvene by 31 minutes after. Okay. Welcome back, everyone. Okay. Yes. Okay. So let's continue with the next part of this class, which is cross-contract interactions. And we're going to create 2 contracts. I'm going to be a bit fast about writing the contract. Then I'll write all of the contract, and then I'll come back and explain what they do, right? So yeah, so it should be a lot faster for us, since we all now have a good grasp of how to sort of like write contracts and what we need to do when we're trying to write our contract. So yeah, these 2 contracts are basically, first one is ERC20 token contract with basic functionality, which is basically, yeah, which will basically have sort of like we basically have some sort of something like how will I put it? Something like name, balance of, and transfer, right? And then the second contract will have its vote contract. We basically want to have deposit, withdrawal, and get balance. So yeah, I'm going to sort of like go ahead and write all of this, right? Create the functions, deploy it. Sorry, create the scaffold, the contract, write the interface, implement the functions, and then I'll explain what I did. Then I'll go back and create the other function, the other contract, write what I did, and then explain. Then I'll explain in details where there's the contract interaction between the 2 contracts. Then if time permits us, we will deploy the classroom contract and see it live on testnet. Are you guys with me? Can you guys give me an emoji if you guys are with me? Okay. Going to go ahead and I'm going to go ahead and see. Yeah. Awesome. So I just scaffold the project. So I'm going to go ahead and import it in my workstation. Okay. Okay. So this is our this is our sort of like, so I'm going to do ERC20.Cairo. Yeah. And what do we want to do here? We said it's a contract that allows you to sort of like so I'm going to copy some stuff from here. Basically this interface, basically almost all of it, right? But then do some changes, remove everything that is here. I'm going to call it ERC20. Okay. Somebody trying to speak?
Yes.
Eric, okay. Yeah, you can go ahead.
I don't know if it's just me, but I think I feel exhausted. If it's something that we can continue on Friday, I don't know, maybe it's just me. Let's take time and assimilate these ones we've already done.
Okay, let me hear from other students here. Should we move this class? Like, should we consider this class on Friday?
Yes, sir. Let's move it to Friday, but let's finish the ERC20 first.
Interesting. So okay. So should we finish this current contract we're writing? Then we move the class to Saturday to Friday. So Friday class is not a long one, right? Because it's basically recapping of what we've done during the week and then giving the week assignment. So yeah, do we all agree we should complete this ES20 contract and then we adjourn to Friday, complete the second contract, the contract interactions, and then we give her the assignment? Okay. Yes, I'm definitely going to deploy this, like push this code to GitHub and share the link. The two contracts that we just worked on, the classroom and then the contract that we worked on. So yeah, let me go ahead and implement the interface, implement all of the functions of the contract, and then I'll explain to you guys what I just did, and then we can come back. Then we can end the class and reconvene on Friday, same time. So here we're going to have fn name, and what would name do? Name it basically tell us the name of the token. Yeah, basically tell us the name of the token. So we're going to have, it's going to take a snapshot of the contract, children FL2252. Yeah, then we have this, and what would this do? This will basically give us balance. Okay. An address, and it's going to return us U256. Yeah. Then the other one is going to be FN transfer. And it's going to be ref, it's going to read state, it's going to change state. Yeah. Then track state amount to 256. Yeah. Yep. That is it. Yeah, transfer, then the recipient. Yes, who's going to receive the amount? Yeah. Recipient. Okay, contract address. Awesome. Yeah. So the next thing we want to do is create our contract. Yeah. Going to do this, right? Okay. Pop mode ARC20. Yep. Okay, it's supposed to be mode, not mode T. Yeah, awesome. So ERC okay. Super IERC for now. Okay. We want to use Starknet or Starknet. Call the Starknet contract address. So next thing we want to do is we want to define our storage. And our storage I was expecting it to auto compile, but it did not. So what we want to do is we want to collect the name and balance it. And balance is going to be a map of contract address and the U256. And what does U256 does? So because it's a map, and we definitely want to read and write from that map, we can essentially pick up something from here. Yeah, what we discussed, right? Storage. Okay. Well, 252, awesome. Then we define our constructors. Every time you deploy an ERC20 token contract, you sort of like define constructor. Okay. Seems like the compiler is angry with me, does not want to give me auto compile. Contract state name is file 252. and we want to do self dot name dot write, and don't have name. Yeah. Okay. The next thing is we want to make it external, not ABI. So that external means other contract can call it, but it cannot be called from outside of the contract. So we'll say implement ERC20 implement of ERC20 okay. Contract state. I expect this to shout now. But why is it not shouting? Can anybody point to why this thing is not shouting?
Oh, it's stranger.
Yeah, it's actually strange. So because it is an external function, but I expected it to shout, but why is it not shouting? Contract state. Okay. Maybe the compiler is tired. It's tired of us. Just wants to. So now we want to get the name right. Basically, say self.name.read, right? Balance of. You want to do self.balance of, right? Balances dot read, and you want to read against this address. So yeah, the account. Yeah. Account. Yeah. So the bulk of our work is with the transfer. And mind you, this is just a simple implementation. There's really no security consideration taken into place here. Yeah, so you can implement it to transfer in whatever way you sort of understand, right? But this is just a simple flow that I just did, sort of like move us ahead. So now the sender is the guy calling this function. So let's do sender. And remember, we can always get this get caller address from here. And I need to go up and add this here. After getting the sender, we want to know the sender balance so that we know because he has a amount he's trying to send. And the way we do it is we do self dot balances dot read, and then we pass in sender. Yeah, because sender is a contract address, so we can pass it here to know his sender. Then we'll do an assert. if sender balance is greater than or amount. So if this is false, it's going to show an error. Insufficient balance. Okay. Okay. Insufficient balance. Okay, hold on a second. Okay. Then we go ahead. Yeah. Now self.balance.write let new sender balance be sender balance minus amount. Yeah. Then we write self dot balances dot write dot sender but new sender balance. Okay. That token recipient balance. Yeah. So we want to do self dot let recipient new balance. We also need to find a way to read his previous balance. Yeah, self dot balances dot read recipient, right? Then recipient previous balance plus amount. Yeah, then we do self dot balances dot write recipient and recipient new balance. So yeah, this is it. And yes, very important, a very important key concept is in every time you're trying to do transfer in contract, always return the bool value. Yes. So yeah, this is it. Now we just finished sort of like implementing the token contract, Scarb, FMT, okay, 45. Okay. Try an error that it let me see. Oh, okay. So it's showing an error that we did not close it. So ERC20 token is complaining that it can't find super. Let me see. Oh, I totally understand. It can't find super. Use super. So there's something wrong with the super I'm using. Exactly. So I'm not using super key here. So, but yeah, this should sort that out. Yeah. So then the bool supposed to yep. So yeah, this is it all about the ERC20 token contract. It's just a basic token contract that basically define token name and then add the balances of people that have that token. So yeah, and then the transfer. So yeah, we're going to call it a day from here, right? And then on Friday, we'll continue from where we stopped here. Complete this contract, do like work on the other vote contract, interact with this contract, so you get to understand how cross contract interaction works, right? And then we'll talk about the assignment and we call it a day. So yeah, does anybody has any question at this point that I can answer? And if not, we can call it a day and to meet on Friday. Okay. So see you guys on Friday. I'll be sure to deploy this to push this two contract we worked on. The one we worked on Monday and today. I'll put it to GitHub and then I'll share the GitHub link with you guys in the group. Yeah. Thank you everyone. See you guys on Friday. Bye.
Bye. Thank you, sir.
Yep, thank you.
Thank you so much, sir.